Today's lesson is going to focus on intersecting arcs from various positions in a circle. So we're going to look at what happens when angles, the vertex of angles that intersect circles are on the circle, inside the circle, and outside the circle. Several different things are going to happen, and you're going to have to remember several different formulas. The first one is a central angle, and we know that this is obviously an inside the circle situation where our center and our vertex are the same. We know that this angle and this arc have the same measure. This one is review. So when we look at our example of angle X, we know that X is 114. To find Y, we know that the distance all the way around a circle is 360. And so Y is 360 minus 114. And we know that Y is 246. Now that's review. What happens when things get a little different though? What happens when we have an inscribed angle so that the vertex is on the circle? It's an angle whose vertex is on the circle. Well, we can't do equal because that's when it's at the center. And so what we know now, if I call this angle X, that the measure of arc AC is going to be equal to 2 times the measure of angle ABC. So in effect, AC is 2 times X. And while pictures lie, that should visually make sense that the arc would be bigger. Now that's important because a lot of times students get this backwards. We can also say 1/2 of the arc is equal to the angle, because taking 1/2 and multiplying by the 2 are the same thing. So it's whatever's more convenient, but remember the angle's always smaller than the arc. So always stop yourself to make sure that you have that multiplying by 2, dividing by 1/2 in the correct order. So this example seems very large, very complicated, but if we break it down, it's not so bad. So the first thing that I see is that angle X is an inscribed angle. Here is its arc. So X is equal to 1/2 of 100, and so X is 50. I'm going to skip Z for a minute because I'm not sure what's going on up there. I'm going to go over to Y because Y is also part of an inscribed situation, except this time I know the angle is 34, so I know that Y is 2 times 34, which is 68. Now to go back to find Z, I need to think about this whole circle for a minute because I really need to know this arc. And the arc that goes with it, let's just call that A for a minute, is going to be 360 minus all the other pieces. So minus 62 minus 100 minus 68 minus 76. And so I know that that arc A is actually 54 degrees. Once I know that Z is 1/2 of its arc, and so I know that Z is 27 degrees. So between the 360 bit and our new arc formula, we can find all of the missing parts of this circle. And looking at another example to find X, it initially looks like, again, we don't have enough information. We're after this angle right here, which would be related to this arc. Let's call the arc W for right now. I know that that arc and 254 are related. So if I take W would be equal to 360 minus 254, I know my arc is 106. Once I know my arc is 106, now x is 1/2 of 106, or 53 degrees. So sometimes you have to do multiple calculations to get the piece of the arc or the angle that you are after. Now we have a different scenario. What if we have a chord angle scenario? So again, we're going to intersect inside the circle. Okay. So we're talking about two chords intersecting in the circle, but not at the vertex. Because if we're at the vertex, that's a central angle, they're equal, life is good. But in this case, we need to use something else. And what's going to happen is that this angle right here, we'll call it angle 1. It would work for any. Obviously, we have vertical angles, so we know these guys are the same. But looking at those two that I've marked in red, the measure of those angles is going to be 1/2 of arc AC plus arc BD. So basically, it's the average. So you're going to average the intersected arcs to get the angle. Okay, if we wanted to find the other sides, we could do that with their arcs also. So let's look at an example. In this case, I'm going to work X first. These two angles are the same. They are related to these two arcs. And so I know the measure of angle X is going to equal 1/2 the intercepted arcs, 77 plus 43. And so X is 1/2 of 120, which is 60 degrees. Once I know X is 60, then it's a matter of simple linear pair to get Y. So just remember, if I intersect inside, not at center, it's the average of the two intersected arcs. Now there are three scenarios that can result in an intersection outside of the circle. Intersection outside of the circle. We could have two secants intersecting out here, and if we're trying to find that angle, we could have two tangents, or we could have a tangent and a secant, all creating an intersection outside of the circle. What our formula is going to be in this scenario for all three of these is that the measure of angle X is going to be 1/2 the big arc minus the little arc. So you subtract the big arc for here, AC, minus BD, and take 1/2 of it. In this case, 1/2 of AB minus little ab. Here, we would take 1/2 of AC minus BC. So if you just remember big minus little and take 1/2 of it, again, the angle is smaller. That's where the half is coming from. So let's look at a couple of examples that deal with our 1/2 big minus little. So in this scenario, I'm after X. I don't initially know this big angle. It's not given to me, but of course I can find it because I know this part is 170. And so if I take 360 minus 170, I have 190. Yep, check my math. Now I can say that angle x is equal to 1/2 of the big angle is 190 minus the little angle. And so I have 1/2 of 140, which is 70 degrees. So as long as you're remembering that big minus little, it's pretty easy. In example 2, I've given you the angle, but you're missing the big arc. So again, fill in what I know. I know that 32 is going to be equal to 1/2 of x minus 20. Now this just becomes an algebra problem. How do I get rid of multiplication by a half? I multiply everything by 2. So I have 64 is equal to x minus 20. Add 20 to both sides. 84 is x. And this last one, again, we're missing the angle, and it initially seems like we're missing the little arc. But again, we know all the way around is 360, so that means that this little guy down here is 110. And so x is going to be equal to 1/2 of 250 minus 110, which is 1/2 of 140, which makes this one 70 also.